Hi, today we're going to learn about graphing linear relations. So to start off, we have a problem here. It says Brandon makes custom tables. Each table has two supports made from metal tubing. The height of each support is 60 centimeters and the width matches the table width. Brandon has altogether 380 centimeters of metal tubing. What is the widest we can make the table? So here I have a picture of our table. So both legs are 60 centimeters high, and we have the width is the same as the width of the tubing. So first step to solve this question, I'm going to say is we're going to make a table. So let's quickly make a table here. Okay, so here I'm going to have my width, and here's going to be my total centimeter. Okay, so if I start at a width of 10, what am I going to have for total centimeters? Well, let's look at this. So we know my height is 60, so I have 60 plus 60 is 120. And then these heights here are 60 as well, so that's now 240. And then my width is 10, so 240 plus 10 and 10 is going to be altogether 260. Okay? So let's see, I'm going to go up by 10s if I go a height of 20. If I go a height of 20, same thing again. I have 60 plus 60 is 120, and 60 and 60 is 240. And then I'm going plus 20, and 20 is 40. So 240 plus 40 is going to be 280. All right? Now let's try 30. So if I have 30, once again, we have 60, 60, which is 120, 60 and 60, which is altogether 240 altogether. And then we have 30 and 30, which is 60. So 60 plus 230, or 60 plus 240 is going to be 300. All right? And I'm going to continue this. 40. If I do that again for 40, because remember, 60, 60, 120, and two more 60s is going to be 240. Then we have 40 and 40. Okay? So it's going to be 240 plus 80 will give me 320. All right, so now we want to make a formula for this. So step 2 is making a formula. Let's look at my table. Every time here, I'm going up by 10. Every time here, I'm going up by 20. I go up here by 10. Here, I'm going to go up by 20. Once again, by 10, and here by 20. So for every 10 this goes up by 20. So then by every 1 this goes up, how much would this go up? Think back to our ratios. It's going to go up 2. So I have to multiply my width by 2. Okay? So my length, or my total, is equal to 2 multiplied by the width. And then what must we always add? We're adding 60 plus 60 plus 60 plus 60. We're always adding 240. And that would give me my total length. All right? Now, for step 3, we want to graph this. So we're going to try and graph that table. So I have my graph paper here, and make a quick graph. Okay, so here's my graph. And I am going to count by tens. Okay, so we want this will be starting at 10. This will be 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? Because that there is my manipulated variable. It's the W. The manipulated variable, the one right here, is always going to go down below. Okay, the one we're trying to find out will be mostly there. Okay, so we are always going, so if we have 10, our first one is right there to 60. So I'm going to have to start counting up. So I'm going to count by 20s here. Okay, so now I have my graph done. I counted all the way up to 420 on the side, which I really only need to go to 380 because of my question, and all the way up to 100 on the bottom. Okay? Now, this is going to be my total length, and it is in centimeters. So we have to put that in. This here is going to be my width, so put our title in, and that is in centimeters. Okay? And what are we doing? We're going width versus total length. My title, which I'll show you up here, is width versus total length. Okay? So there, now we have my titles, and we could start displaying my graph. So if we remember, at 10, we had a total of 260. So at 10, we're going to go all the way up to 260. At 20, it was 280. Okay? At 30, we were at 300. And at 40, we were at 320. If we look at this, it's starting to make a straight line. So with this straight line, I'm going to highlight 380 because we want to go all the way to 380 because we're getting our pattern. So it's to right there. Okay? So I'm going to go all the way like this straight to 380. So at 380, now I'll follow this all the way down because that's where it'll intersect the line 380, and I'm going to end up getting 70. So when the width is 70, that's the max width we could have, we'll have 380 total centimeters. And that is the max amount of tubing he has. Brandon only has 380 centimeters of tubing. So my answer for this is the width would have to be 70 centimeters. Okay? So we'll go over that one more time. Basically, I made my graph. Okay? Made sure I labeled my axes. I counted by 20s going up, and I counted by 10s going to the side. Then I plotted my data points. I said 10 was equal to, 10 width was 260 total, so I put my data point. 20 was 280 total, or was 280 total, so I put my data point, and 30 was 300, and so on. And then I looked, it's making a straight line, so I was able to connect it and anticipate my next point, or judge where my next point is. Let's say if I only had 325, I would go right to here and go all the way down there, and I'd say it's 45 centimeters. Okay? So that's, when we make this line graph, it really helps us estimate and interpret what could be our values without actually doing the calculations manually. Okay, so now let's look at question number 2. It says make a table for the equation starting at -4 to 5. So let's look at this equation here. Now we're working in reverse. We're already given the equation. So we said y is equal to 2x minus 2. So I'm going to say this is my x and this is my y. So when we want to start at -4 for x. So when I have -4, what would my y be? So I have 2 multiplied by, so I send 2 multiplied by -4 will give me -8. Then we subtract 2, which will end up giving me -10. Okay? Now the next one will be -3. So if I did 2 multiplied by -3 and subtract 2, that's going to give me -6. Subtract 2 is going to give me -8. All right? So let's do this again. We're going to go -2. So if I did that here, I'm going to go 2 multiplied by -2, subtract 2 will give me -4, minus 2 is -6. I think you're starting to see a pattern here. So we take a look at -1. So -1 times 2 is -2, minus 2 is -4. Now let's take a look at 0. 0 times 2 is 0, minus 2 is -2. Okay? And then we're going all the way. We have 1. 1 times 2 is 2, minus 2 is 0. And I'm going to just continue this like this. So I have 2, and what are we always going down by here? We're going up by 2. The difference is always 2. 2, 2, 2. So I could go, this next one will be 2. And if I have 3, it's going to be 4. 4 will be 6. And we keep on going down. All the way to 5, 5 will be 8. Okay? So when we graph this, we have to look at something here. My x is always going to be this one, and my y is always my up and down. So it says when x is -4, I'm going to have to go this way. So I'm going to go -1, 2, 3, 4. And it says y is going to be -10. So negatives are down here and here. This is positive, positive. So I have 4, and then -10 is going to be all the way down there. So that is my first point, -4, -10. Let's look at my second point, is -3. So -1, 2, 3, and then -8. So I count 8 down. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now my next point is going to be -2, -6. So it's going to be -2 all the way to -6. Look at this once again. We are making a straight line. Notice it's called, what we are doing is we're making graphs for linear equations. We're making linear graphs, straight line. So I'm going to continue this up, and we're always going, every time we go over 1, x increases by 1, this is increasing by 2. So I'm going to go over 1, up 2. Another way of looking at it, over 1, up 2, over 1, up 2, and we keep on going like that. And we end up getting a straight line that goes like this. Oops. Okay. And we only go to point 8. Because it says it wants us to graph from -4 all the way to 5. And this here we go is 1, 2, 3, 4, 5. So we only go this far. And that is how our graph goes. Okay? So we made a table, and we did our graph, and we connected the dots. All right, let's take a look at our last question here. It says, Isabella manages an amusement park and is checking on the wait times for different rides. She made this graph to show how a customer moves forward while waiting in line for the free fall ride. What does Isabella's graph show about the relationship between time spent and the customers in the position line? So we look at this. This is how long you waited and what position you are in the line. So a person who just arrived here at 0 is in position 180. If they've been waiting for 2 minutes, they are now position 156. If they're waiting for 4 minutes, they are now in position 132. They waited for 6 minutes, they are now in position 108. So this person right here, who's in position 36, they would have waited already 12 minutes. Okay? So this graph helps her explain how long it takes you to get there. Now, if we were to continue this graph, if there's 180 people, it would take you all the way to, if I look at it, just past 14. So it looks like 15 minutes is how long this person would have to wait until they get to the front of the line. In position 180, they would probably wait around 15 minutes to get to the front of the line. Okay? And so that is mostly what you need to know about line graphs. We'll learn a bit more later, but for now, that is all you need to know.